Alright, so in the previous video, we discussed our 1-bit adder, and we showed how to create the A plus B section of our adder. Recall that we did that simply by exclusive ORing A and B, and exclusive ORing C with the result of the A-B exclusive OR. A bit of a mouthful, but if you go back to the previous video, you'll see exactly how we did it. Now we're going to be discussing the carryover, which simply feeds into the next calculations carry, and will tell which again tells the next step whether or not they need to carry or not. So let's just sort of get started with that. Here again we have our truth table. I'm just simply going to go ahead and underline the conditions that are true. And start working on our predicates, so maybe we can try to understand how we might create this. So let's take the first condition. Again, very sloppy of me. I apologize. I'm so sorry. I have to do grids next time. But the first case is B and C. So we have our not A and B and C. Our next condition is A and not B and C. And our next condition is A and B and not C. Quite the pattern we have here. It's kind of like we simply have to, if we recall last time, for A plus B it was one must be true, the others must be false. But for this one, it seems that the opposite is true again, but the last case is still true, with that being all of them must be true. Basically what I'm trying to say is for the first three, 2 must be true instead of 1 from our previous circuit. And again, they both both share the last condition, in which if all 3 are true, then it's all good. So let's start thinking about how we might create this circuit. We want 2 to be true. So 2 must be true and 1 must be false. So really, you guys might want to take some time, maybe pause the video. Maybe now would be a good time. So maybe you guys can discuss and think about how you guys might implement this circuit. It's a really interesting one and quite simple once you see it. Okay, I'm just gonna assume you guys have done it by now. You guys have had more than plenty of time to pause. So if you haven't, pause now and fix it. Otherwise, we'll be getting to the final solution. So let's just go down. Okay, too far? Okay, I think right here is good. We'll just select a pretty nice color to write with. And we're going to go with A, B, and C is our carry. So again, if we just look at these, 2 must be true. So how can we guarantee that 2 are true? Well, again, we have to think of always try to break things down to 2, because our gates have they have bi inputs, so they have 2 inputs and 1 output. So if we really try to break this down and just maybe look at it like this, sort of breaking this down. How can we sort of substitute this? And I think we have a pretty interesting answer. If we just look at the first 2, we see that either or must be true. Either or. What does that make you think of? The exclusive OR gate. So this is we're not necessarily working on our final solution. We're just brainstorming right now. We're just working towards our answer, right? Just by analyzing the first 2. So it's either or and C. So either or and, let me make logic gate for and C. Okay, that's a good start. That's a really good start that we have there. But then we look at this one. It's A and B and sorry, and not C. right? So I mean, if we think about our circuit right here, I mean, we would have so this is what, filling the third condition. So it's 1O. Sorry, it's A and B and not C. So you know, what would happen is we would end up having something like this: 0, 0, and of course the output would be 0. And clearly that's not what we want. But hey, you know, we were pretty close. So what if we just take A and B and AND it together? Let me use a different color to signify sort of, you know, to sort of signify that we're solving the next problem. And you know, we're drawing our logic gates. If we see any reductions that could be done, like any way we could simplify it, yeah, we'll do that. Right? But this is sort of a bigger one, so okay. So let's take A and B, and we're just gonna AND them together. Okay, perfect. And of course, we have a not C, but we don't really have to worry about the nots too much. We don't have to worry about the not for that case, because again, A and B have, I mean, if both are true, then we're good, because consider the case where A and B are true, right? So we have A is true. Sorry, let me just write A, B, and C. A is true and B is true. If C is false, then we are okay. This is legal. If C is true, it's also legal, because the last case we have is A, B, and C all true. Hopefully you guys can see that. See that? Okay. Sorry guys. Bad fun, I know. But hopefully you guys see the circuit that we've created and see that it's actually valid and that it solves this. And again, we just need to simply OR them. Hopefully I'm explaining this right. If not, mention in the comments and maybe I'll redo this video. But I mean, to me, hopefully you guys can all see it, and that I'm not just beating around the bush, and that I'm not beating a dead horse. Okay, so with these two circuits, I'm just simply going to now very poorly and OR them together. Oh God, that's so terrible. Please forgive me. My organization is very poor. Okay. We don't really care about the result of C so long. If A and B are true, we don't care about C. Honestly, it doesn't matter because the result of C will not change the overall result. The only time in which we care about C is when A or B are both not true. In which case one of them must be true and C must be true. Okay, so let's just go down. Let's quickly do some tests. So we'll start with the first one. So B and C are true. We'll select a pretty color for this one. Okay, so false, true, and true. So we'll start with the green one. Exclusive OR, that is true and true. We AND them together. The result is true. I mean, we're pretty much done there. Let's just go ahead and do it for this little one, our second, sub-circuit. Again, this is false and this is true, so the result will be false. So false ORed with true results in true. Okay, so the first case we're good on. Let's look at the second case, 101. 101. I'm just going to go ahead and blaze through this because I kind of want to make this video really short. 0, 0. Exclusive OR 1 and 1, 1, 1. As you can see, we have AB exclusive OR yields true, and C ended with the AB exclusive OR results in true. And then when we OR that with the other with AB and that yielded false. So, but it's okay because our previous sub-circuit yielded true. So, we're good there. is going a bit long. Let's finish this up. Okay, AB true. Okay, AB true, you guys should be able to see that. I mean, come on. It's literally right there. And then we OR. It doesn't matter what the result is of the other one. And lastly, all three are true. Okay, AB are true, so it doesn't even really matter. I'm so sorry, guys. I'm rushing through this. I just want to show you guys and, finish up the video real quick. Hopefully I can get it under 12 minutes. Okay, so hopefully you guys see this. Take AB exclusive ORed. So AB exclusive OR, and then AND that result with C, and then have A, B, AND together, and then OR those two together to yield our final thing. And so here's our final circuit. I'll show you guys in the next video how to make n-bit adders, but right now this is just our 1-bit adder. Again, follow the link down there, and you'll be able to play with it yourself. I would strongly encourage you to play with it, double check it, but I'm going to show you one quick sample. How about that? We'll do this one, 101. So 101, A plus B should be false, and it is. And the carryover should be true, and indeed it is. I'm so sorry for this video being rushed. Time management skills are very poor. In the next video, hopefully we'll be able to go a bit slower, and I'll show you how to expand this, and hopefully we'll be able to drive home the point that we've learned. One interesting note to see is that, as you can see, I don't have another exclusive OR for A and B. I just simply borrow the result. So that's what this one does here. Okay, guys, thank you so much. Look forward to our next video.